Okay, this topic is max and mins. Real specifically, there's two types of max and mins. There's absolute, and then there's these max and mins called relative or local. We're going to talk about absolute today. And right now we have a function drawn here, and we're calling this function f of x. Let's imagine that f of x, had an equation. How about f of x equals x cubed minus 12x plus 1. I could ask you all sorts of questions. Like I could start asking you, well, where's the highest and the lowest point on this graph? But I need to give you an interval. So let's say I want to study this graph from -3 to 5 and figure out, oops, let's put a bracket around that, from -3 to 5. Well, graphing this on a calculator is really easy to do, which is how I got my graph so quickly. But if you were to be in a non-calculator situation and I ask you from -3 to 5, where's the max and min? Well, you might have a little bit of trouble. I know -3 is somewhere over here and 5 is somewhere out here, but I need more detail. So what we're going to do is use a different process. We're going to use something called critical numbers to figure this out. Critical numbers are when the derivative of this graph equals 0 or does not exist. So let's go through the process. Imagine you don't even have this picture, so I'm going to slide this up. You just have this function up top here. First thing you're going to do is find f prime of x. So the derivative is a quick power rule. It's 3x squared minus 12. We're going to take that derivative and set it equal to 0. So why don't we factor out a 3 and say x squared minus 4 equals 0. If x squared minus 4 equals 0, and I add the 4 over, x squared equals 4, and I take the square root, I get x equals plus or minus 2. Those are my critical numbers. It means if I was able to see the graph, a max or a min might be occurring at these points. So now I'm going to get a little more specific. I want the absolute max and min, which means I need to build a table to show some work here. So once you find the critical numbers, remember we wanted to find it on an interval from -3 to 5. Well, let's go down here and write left endpoint. Our left endpoint on this graph is at x equals -3. Our right endpoint, which I'll write down below here, our right endpoint is at x equals +5. We want to know which value, +2, -2, or our endpoints, are going to give us the max and min. So I'm going to write critical number in the middle here. And I have two critical numbers, x equals -2 and x equals +2. Notice I'm kind of putting this in an order. I'm starting up top with the farthest to the left point, the smallest number, -3. And then I'm getting bigger, -2, +2, +5. What I'm going to do is build this into like a big chart basically. So I'm going to split this up into a couple of parts. We want to know what's going on the graph of f of x. Remember f of x equaled x cubed minus 12x plus 1. Well, I want to know what's happening at f of -3. What's happening at f of -2, f of +2, and f of 5. Which, if I don't have my calculator, is still solvable because I'm just going to plug in all these values. If it's x cubed, it's going to be -3 cubed minus 12 times -3 plus 1. Or if I plug in -2, it's going to be -2 cubed minus 12 times -2 plus 1. Plug in +2, it's going to be 2 cubed minus 12 times 2 plus 1. Plug in 5, it's going to be 5 cubed minus 12 times 5 plus 1. Each one of these I can plug in and get a number for. Pretty easily. It's not going to be too hard. So I'm plugging all these values back into f of x. Turns out f of -3, when you work this all out, is 10. F of -2, when you work this out, is 17. F of +2 is -15. And if you plug in the 5s, you get 66. So all these different values. What these numbers are helping us figure out is Well, where's the max and min? Max is going to be the largest point that you get. 66 is our largest number. This must be our absolute max down here. And our smallest possible number was at negative 15, so this must be our absolute min. So I'm going to label it over here, absolute min. That means on the graph, at x equals 2, we have a min. At x equals 5, we have a max. So when you write your final answer, you write x equals 2 is a min, x equals 5 is a max. And I'm going to circle. These are my two absolute max and mins. If I go back to my graph, because we didn't cheat, but in most situations we wouldn't have a picture of the graph, but we did. It was this thing back here at the start. Well, if you look at x equals 2, that's right here. That's our absolute minimum value. And if you look at x equals 5, it's going to be way out here somewhere. I probably didn't draw this to scale very well. I probably should have done a little better at that. But that's going to be where our max is at. So we have our very high and our very low point. Granted, we only studied this graph from -3 to +5. So in between here, where's the largest and smallest value? I should have drawn this a little farther up, I think. But other than that, you get the idea. So max and min. Biggest thing you remember about absolute max and min is it's on an interval. And when you go to set it up, this is the work that you're going to want to show. You're going to show a nice organized table with endpoints and critical numbers. And everything you plug in goes back into your original function, not back into your derivative. That's the biggest mistake people make, is they plug all these numbers back into the derivative. Once you have your critical numbers, you're done with that derivative. You just focus on the old function, the one that you care about. And that's the general idea behind max and mins.